APC Technologies. We're here at World Hydrogen North America Conference doing interviews with thought leaders and some pretty smart people about the hydrogen economy and the hope it has. Our sponsors are, of course, APC Technologies, World Hydrogen Leaders, and, of course, H2 Scan, whose advanced sensing technology for the hydrogen economy. Things are changing rapidly, and you will hear some amazing things from amazing people who are decarbonizing the world and who are moving hydrogen forward. So join us. Enjoy these interviews. Our next guest is Joel Moser. Joel is the CEO, is that correct?
That's correct.
Tell me a little bit of what you're CEO of.
The company is First Ammonia.
But what's your CEO of? Because the company, First Ammonia, I understand a little bit, but I don't think many people understand the role that ammonia is going to play or plays within the hydrogen economy. Tell me a little bit about what the company does.
Sure. That's an excellent question, and it's a question which requires a lot more attention at a conference like this.
Right.
The World Hydrogen Conference is a lot of interest and discussion about hydrogen. We believe, and I hope that by the time we finish talking, I will have convinced you
okay, all right,
that ammonia is a central piece of the hydrogen economy.
Right.
So our company, First Ammonia, will be making, by the end of this decade, 5 million metric tons of green ammonia.
Wow.
Which is a drop in the bucket of the existing world ammonia demand, a smaller drop in the bucket of the demand for green energy products, but will be the largest volume of green ammonia ever produced in the world.
Yeah.
With the possible exception of one or possibly two others, which are also under consideration. But I will tell you that when I speak in cocktail conversation to friends, they ask me about my new company. They say, well, who are your competitors? A decent question. And I say, I have no competitors.
That's a great answer, by the way.
But it's not because I'm cocky and saying that no one's as good as us. I mean it in a different way. We have no competitors because we need everyone to succeed.
Okay.
For our product to be in demand, it needs to be in use. For it to be in use, there needs to be a sufficient volume of it available so that those who might use it will do the things, and we'll talk about them in a minute, changing turbines, changing ship motors, to use ammonia. So there needs to be a robust volume of this product available. And so for that to happen, I need to succeed, and everyone else trying to do what I do needs to succeed. So in that regard, I have no competitors.
I can see, and we're going to get around to that because what you just described is the great need for collaboration to accomplish everything. Infrastructure's got to stay. That won't happen if demand is far outseeding supply. You got to make sure the supply meets the demand. Excellent.
Yeah.
Talk a little bit about. I wrote an article for my own publication, so but it got republished in Energy Central and other places, and it was very simple. It was hydrogen, hype or hope, because there's a lot of money being thrown at this, both from governments, a lot of capex coming in now. VC peoples are here at this conference going on. What is your take on hydrogen, hype or hope?
There's a lot of hype, and there's a lot of hope.
Now, that's a great answer, Joe. But you're right. Yeah.
But there's a lot of promise.
Okay, that's a great.
There's a lot of promise because hydrogen can replace hydrocarbons as a fuel source, and it can happen within a reasonably short period of time. Not entirely by the end of this decade, but certainly within the timelines that we hope to achieve carbon neutrality in the world. Now, if I can just back up, and if I back up too far or go too off track, you're going to stop me out.
Right.
We need lots and lots of renewable energy.
Right.
Lots of generation and lots of transmission.
Right.
As a world, we seem better off making it generation than transmission. It's an issue that needs to be solved. But there is a limit to electrification. There is a significant component of the global economy that cannot be electrified for a number of reasons. One, of course, is just transmission as a practical matter. It will take decades, if ever, before we're able to extend electrical transmission to the entire global economy. There are parts of this world with hundreds of millions of people that will never, in the decades to come, have significant power transmission. So if you want to decarbonize those areas, primarily developing countries, rural areas throughout the world, you can't be talking about electrification, not anytime soon. Then you've got long distance shipping, long distance air travel, heavy road transportation, and then ultimately power storage. Okay, so for these kind of long distance regions for which electrification will not reach anytime soon, transportation efforts, you need a fuel. Now, why did I mention power storage? Because batteries are expensive, it's impractical. How do you store power? Why do you want to store power? Because renewable power, by definition, is intermittent in its production. When it's sunny, when it's windy. There are significant inefficiencies in when power is produced and when it's used. Okay, this is a challenge, but it's also an opportunity. Sometimes there's more renewable, and if you can imagine a world where we build out as vast of an enterprise of renewable power as will be required, there'll be significant inefficiencies. There'll be times when there's way too much power produced. What do you do with that excess power? Well, you make hydrogen. You make hydrogen. But hydrogen's expensive and practical to store. It's the smallest molecule. It escapes. It takes tremendous pressures to store. Convert it to ammonia. That one little bit of nitrogen grabs a hold of 3 bits of hydrogen and calms them down. Ammonia can store at normal kind of pressures, about the same as propane, and can last indefinitely. So capture that excess electricity, store it as ammonia, and if you want to think of it as hydrogen, just think of it as a hydrogen product.
Hydrogen capture. I really never understood the massive role that ammonia could play, because that makes sense. Storage, in my opinion, as a reliability, an electrical reliability guy, storage is our problem. Renewables create a problem. You've got an opportunity. Excellent. I understand that.
Ammonia is the chemical battery.
Yeah.
We've been talking, you and I have been talking for a very long time. This is the first we've met.
Day, right.
But we each have been in many conversations and read many articles about the huge challenge of renewable power is storage.
Yeah.
Batteries, expensive and practical, require significant amounts of material, metals. Right. We talk about pumping water up a hill, all kinds of, okay. The solution exists. Ammonia is a chemical battery. Stores indefinitely. In the future, I am certain, we'll come back and talk in 40 years, you and I. In the future, the electrical grid will be powered by renewables with ammonia-fueled peaker plants. Now, it's the future because it'll take that long to build out the renewables, but it's also the present. So Mitsubishi Heavy Industries is about to start delivering, I think in about a year, its first pure ammonia-fueled turbine generators. This is the present. So hope, hype, but it's reality.
Yeah, right.
The promise is the present. Mm-hmm. And GE and IHI are also developing their own. So the turbine generators that run on pure ammonia. Japan is converting over time its power system to ammonia. Japan is a small country with a big population, doesn't have hydrocarbon resources adequate for its population, doesn't have renewable resources for its population. It needs to be an energy importer. It wants to be a responsible citizen of the world and decarbonize. It has figured it out. It's going to import ammonia and use it as ammonia, and I want to come back to that because there's lots of talk about ammonia as a hydrogen carrier. Yes, it is. But then cracking it back into hydrogen, unnecessary, expensive, a waste of more renewable power. Japan is already there. Use ammonia as a fuel. So in the future, the peaker plants will be ammonia. In the present, Japan is already getting ready to introduce ammonia as a fuel. Both Mitsubishi and GE are going to commercialize. This is going to make me sound like a total nerd, but to me, this is one of the most exciting things.
Okay, nerd out, Joel.
And you need to get the baseline information to then understand why it's exciting. But it is. I think you understand it, and I think the folks who will watch this might understand it. Okay. They're developing drop-in boiler replacements. So you can take a brand new combined cycle natural gas-fired turbine generator like most modern power plants are. Wow. You don't have to scrap it. You don't have to retrofit it. You replace the natural gas boiler, which is the thing that burns that, for an ammonia boiler. That's it. Why does that matter? Well, you've heard about hydrogen pipelines. Well, I'm sure many folks are talking about it. They're expensive, they're complicated, and they will leak, sadly. Yeah. When hydrogen leaks, it combines with molecules in the air to produce greenhouse gases. Yeah. Ammonia doesn't need pipelines. How do you get it around? How do you provide fuel to these power stations? Well, most power stations in the world are sited on navigable bodies of water because they were originally coal plants.
Right.
And they were replaced with gas, but they still sit by navigable bodies of water. Of the 185 million metric tons of ammonia used and produced today, mostly for fertilizer use, about 20 to 30% of it moves around by ship. There's millions of metric tons of ammonia that have moved around for decades and today are moving around by ship. Many of the major ports of the world have ammonia storage and handling facilities. You then can put it on a barge. There are hundreds, if not thousands, of ammonia barges in use today to move ammonia around. So you move the ammonia on a barge to a power station the same way historically you moved coal to a power station. The transportation infrastructure to have ammonia to fuel power stations already exists. Yeah. It will have to build some more. But this is a simple way. Yeah. That's the role that ammonia plays. Ammonia will be the enabler of the hydrogen economy. There's the World Hydrogen Conference. The hope, the hype, the possibility is real. But to actualize, to make hydrogen an energy source for transportation, for power generation, you need ammonia to make it practical.
I'm sold. There. I understand it now. That is brilliant. Last question for you, and then we got to wrap it up. Everything you just talked about requires a lot of collaboration. And we see in the past in certain technological things, there was silos built because of money usually. But now the governments, the VC sector, they're all saying, could you all work together? You just mentioned areas of collaboration. I think it's brilliant. Don't change the infrastructure, use the infrastructure. Because a lot of talk about, change the infrastructure ain't going to work. Financially, commercially, it's just not going to work. What you've talked about is already there. Talk about, just as it is, collaboration, ammonia, hydrogen, the infrastructure, and the concept of collaboration.
We would not exist as a company without collaboration. Okay. And let me I hope I get everybody, but let me start with the most important one. We are partnered with Topsoe. Topsoe is an 80-year-old chemical engineering company based in Denmark. Right. They're building solid oxide electrocell, SOEC, solid oxide electrolyzer cells. Okay. It's a mouthful. Yeah. This is the piece of equipment which takes water and splits the hydrogen from the oxygen. Right. We are their launch company. We would not exist as a company without that collaboration. And it is a true collaboration. It's a true partnership. I was at the groundbreaking ceremony 2 weeks ago in central Denmark where they inaugurated this facility which will make the first SOEC electrolyzers. It's the largest electrolyzer manufacturing facility in the world. We would not exist without a collaboration with Topsoe.
You know, it's funny. I'm going to be interviewing Topso, so I get to talk to them about the other side of it, because I am talking to them about SOEC.
Yes, you'll speak to Olga or Bo, who are here. We know the whole team. I have spent about a week a month in Denmark for about 2 years.
Wow.
That is a true partnership. We are also collaborating with the Port of Victoria in Texas, where our first facility will be built. And with us today at this conference is the Executive Director of the Economic Development Corporation of Victoria, the head of the Port of Victoria. It is a true collaboration. They are with us every step of the way.
Excellent.
And then finally, it's a looser collaboration, but we are collaborating with the federal government because the IRA, the Inflation Reduction Act, provides a tax credit for the production of green hydrogen, which really helps a lot.
Yeah.
It really helps a lot. It helps our business model. It makes the economics work. So there's a public-private partnership with the federal government. So the federal government, the state, the local government, the port, but our technical partners at Topso. And ultimately we'll be collaborating with investors and off-takers. Everybody wants to make this work. It's very difficult to bridge the desire to be investing and participating in the energy transition with the very real demands of the economy, of investors, of commercial partners, to meet the objectives of their shareholders, of their investors. This is the challenge, and we are struggling together to get there in a collaborative way.
So my article, I would have changed it, and I would have said now hydrogen, more hope than hype. Joel, thank you so much.
It's a pleasure, Alan.
I've learned things.
Thank you so much. It's been a pleasure.